Hello Candles, welcome to Candela Learnings. My name is Albert Bonnie and today we continue with the chapter Probability. The topic for today's session is different event types. Now before moving on to what are the different event types, let me start with a simple question. I have two boxes here, box A and box B. They are similar in one way. Both of them have black balls and white balls. Now box A have 6 black balls and 5 white balls. Box B have 5 black balls and 4 white balls. Here is a question for you. If I have to ask you to pick between both of the boxes, in which box do you have the maximum probability of getting a black ball? What do you think? Take 10 seconds and guess. Alright, were you able to guess? Did you pick box A or box B? Well, I'm not going to tell you the answer, but what I'm going to do is I'm going to do a little mathematics to help you understand how to actually solve this question. So, one easy way of thinking of this is, box A have 6 black balls, so obviously it should be box A, right? Like it has 6. At the same time, when you look at box B, even though it has only 5 black balls, the total number of balls are only 9. So, the chances are maybe higher there. Let's see. So, let's first look at box A. What are the number of black balls in that one? It is 6. What are the number of total balls? That is black plus 5. 6 plus 5 is equal to 11. So what is the probability of getting a black ball? This is where your learning from the last session will come in handy. The probability of an event is number of times that event divided by the total number of outcomes. So number of black balls is 6. The number of outcomes possible is 11. So the probability is 6 by 11. Now let's look at box B. What is the number of black balls? It is 5. Total number of balls, interestingly, is only 9. Now what is the probability of getting a black ball in box B? It is 5 divided by 9. Now the answer is right in front of us. Box A or box B? Where is the higher probability? Is 6 by 11 greater or less than 5 by 9? The answer is, well, what is 6 by 11? It is somewhere around 0.54 and few more values. What is 5 by 9? It is 0.55 and some more values. So, which is the higher number? It is 0.55 is greater than 0.54. So, the probability of getting a black ball is higher in box B, even though the number of black balls in that one is lesser. And it's just a 0.1 difference, but trust me, that difference matters. With this one, with this a little introduction of how you can use probability in a real life, let's look at what are we learning today. We are mainly learning 3 topics today: sure event, impossible event, and complementary event. Now, again, I will not tell you what the definition of sure event is, but what we will do is we will look at a question, we will solve each of these questions, and each of those questions will be an example of any one of these topics. Alright, let's begin. Here is a question. Suppose we throw a die once. So I have a die, I throw this once. There are 4 questions given. Let's look at each question one by one. Question number 1. What is the probability of getting a number less than 7? Now, if you have seen a die, I'm sure you have definitely played snake and ladder. So there are 6 faces to a die, and each face is similar in terms of the shape. The only difference is the number that is written there. So there is 1, there is 2, 3, 4, 5 till 6. Now, question is, what is the probability of getting a number less than 7? First of all, let's see how many options are there for getting a number less than 7. Every time you throw a die, the answer will be less than 7, right? So, because the maximum number that could come here is 6. So, your number of outcomes, which is what are the possible outcomes while you're throwing a die is 6. Now, what is the event that we have here? Event E is getting a number less than 7, which tells us that the number of E would be 6 because 1, 2, 3, 4, 5, 6 all are lesser than 7. So, my probability of E will be number of E by number of outcomes. So, that is 6 divided by 6, which is 1, which tells us that for this particular event of getting a number less than 7, the probability is 1. That is, every time you throw a dice without looking, you can tell that this value will be lesser than 7. Pretty, I would say, logical, and even something that you can get there without any multiplication or division. So, what is this kind of an event called? This is what we call as a sure event. What is a sure event? Sure event is an event which has P of E is equal to 1. That is where probability is 1 is what we call as a sure event. For example, while tossing a coin to get either a head or a tail. Now, of course, right, when you toss a coin, you either get a head or a tail. You don't get the number 1 when you toss a coin. It's either head or tail. So, the probability of that event is 1. So, it's a sure event. And the example, while throwing a dice to get a number greater than 0, again another sure event, because throw a die, you will get a number greater than 0 because the numbers are 1 to 6. So, these are examples of sure event. Now, let's look at the next question. When you are throwing a die, what is the probability of getting a number greater than 6? Now, what are the number of outcomes while you are throwing a die? Let's do that first. There are 6 outcomes, right? 1 to 6. The event is getting a number greater than 6. Now, when you throw a die, does that option exist? Of course, no, because the highest number that we can get in a die is 6. So, our number of E or n of E will be 0. So, my probability of E will be 0 divided by 6, which means my probability is 0. Now, you can probably guess what this kind of an event is called. It is called an impossible event. An impossible event is an event where the probability is 0 or P of E is equal to 0. Few examples, while tossing a coin to not get either head or tail. I mean, toss a coin, you either get a head or a tail, man. You don't get anything else. So, that is an impossible event. Another example, while throwing a dice to get a number less than 0. Again, impossible. There is no negative values in this dice. So, that is again another example of an impossible event. Let's look at the next set of question. What is the probability of getting an even number? Let's again first write number of outcomes. While you are throwing a die, there are 6 outcomes, 1 to 6. Now, from 1 to 6, how many even numbers are there? 2, 4 and 6, which means our E, that is getting an even number, the number of E would be 3. So, what do you think is the probability? It is number of E by number of outcomes, which is 3 divided by 6, which will be equal to 1 by 2. Can also be written as 0.5 because 1 by 2 is 0.5. So, this is the probability of getting an even number. Let's look at the next question. What is the probability of getting an odd number? Again, let's go through all the steps. Number of outcomes will be again 6. It's important that we write this every time, because these particular sentences go into our equation. So everything that is coming in the equation, we need to specify at least once. Now, writing the event. What is the event E? It is getting an odd number. Now, this step, as you have seen, I have done this every time, even though it is a little bit of boring copy work. This is important because this is telling the examiner or the person who's looking at your paper that this person knows how to define an event. So even if you got the calculation wrong at the end, you get some marks for doing this. What is number of E? What are the odd numbers? It is 1, it is 3, and it is 5. 1, 3, 5. There are 3 odd numbers in our outcomes. So our probability of E will be n of E divided by number of outcomes, which would be equal to 3 by 6, again half or 0.5. Now, this again has thrown us a very interesting question, that is, the probability of getting an even number P of E is 0.5. Probability of getting an odd number is again 0.5. Now, we almost say that even numbers is the opposite of odd numbers. So, 0.5 plus 0.5 will be equal to 1.0, which means 1 minus P of even will be P of odd. In another words, like I said, odd numbers are kind of the opposite of even numbers. Now, this kind of scenario in probability is what we call as complementary of an event. That is, P of odd will be 1 minus P of even. So, we can say that P of odd is the complementary of P of even. So, if P of E is the probability of an event, P of E dash is the complementary of the event. That is the other side of that particular scenario. So, P of E plus P of E dash, we mention complementary of event as P dash. P of E plus P dash is equal to 1, and P of E dash is 1 minus P of E. Let's do a question to kind of bring this point very clear in our head. Two players, Sangeeta and Reshma, play a tennis match. It is known that the probability of Sangeeta winning the match is 0.62. What is the probability of Reshma winning the match? So there are two people. They have given that one person, that is Sangeeta, will win at a probability of 0.62. What would be of Reshma? Now, you can do this question without doing any calculation. You can just simply look at it. Okay, the total probability is what? One person is having 0.62. I mean, what would be the probability of the other person? It will be 1 minus 0.62. Simple, but let's put it in the terms that we've learned today. The probability of event that is given, that is our E, will be Sangeeta winning the match, right? Yes. And what is P of E that is given? It is 0.62. This is given. Now, our E dash, that is the complementary of this particular event, is Reshma winning the match. Now, how do we find this value? We use the equation that we learned before, that is P of E plus P of E dash is equal to 1. So, P of E dash is equal to 1 minus P of E, which is 1 minus 0.62. The answer would be 0.38. So, the probability of Reshma winning the match would be 0.38. Let's write that answer one more time so that we are clear. Probability of Reshma is 0.38. I mean, it's very easy to check if this answer is correct. You add 0.62 with 0.38, the answer should be 1. If it is 1, then your answer is correct. So, this is how we use the idea of complementary in a question. I hope this concept is very clear for you. We have learned three concepts: sure event, impossible event, and complementary. Sure event is P of E is 1, impossible event P of E is 0, and complementary is P of E dash is equal to 1 minus P of E. There are a lot more questions with these concepts in your textbook. Feel free to check it out. See you again in the next class. Till then, thank you and bye bye.